literally
10,
two spots next to each
9,
other other than the back
8,
row.
7,
Right.
6,
We good?
5, 4,
All right.
3, 2, 1.
Hello, everyone. Welcome to the Rock Game Dev Workshop. So, quick, who am I? If you aren't familiar, I am Sam Camerad. I am the workshop coordinator for Rock Game Dev. And you might be asking, you probably aren't, but you might be asking, what is Rock Game Dev? Well, here at Rock Game Dev, we host workshops here on the last Wednesday, even though this isn't the last Wednesday of every month. We function to bridge between the community, between students, and between hobbyists around Rochester to make cool games and network and talk about our games. We have other events here as well as at the Sibley Space downtown and around the city of Rochester. The next event will be the RIT meetup, which will be 7 p.m. here in the atrium in 2 Wednesdays. So you can come show off your projects, you can get some feedback, you can network with other game developers. Again, pizza and drinks will be provided as they were tonight, but usually you can eat them throughout the talk. Not today. For full list of events and other like Rock Game Dev info, check out our website and the Facebook page. We also have a Discord and Twitter. I'm assuming because you found the room, you may or may not be on the Discord. So some quick announcements. There will be no workshop in December because of the holidays, but I'm really excited for January's workshop, which will be January 29th. Dan Letterman, who was one of the 2 speakers for Rock Game Fest during the keynote, as well as Nicholas Yu, will be giving a talk on how to kickstart your game. And Dan and Nick together have run, I don't even know how many successful Kickstarters, but just recently finished one up. They're fantastic, and I'm really looking forward to that. Again, the RIT meetup will be here in 2 weeks, as well as Rock Maker Fair is, Friday and Saturday? Just Saturday. Steam Fest is on Friday. And they'll be 9 a.m. to 5 p.m. Tickets are on sale now if you go to their website. So, if you want to host a workshop after tonight, you are inspired by Mike's talk, feel free to chat with me after the fact. You can DM me on Discord or Twitter. My handles are up there. Or you can also reach out if you have an idea for a workshop that you'd like to see, even if you don't know who would host that. So, tonight's workshop. I'm going to hand it over to Mike to introduce himself, but he will be talking about Project Antipatterns. This is not relevant. If you didn't already get pizza, you can step out and get it either before or after the talk. And with that, give us like 2 seconds. It's all you.
Wow, that actually was 2 seconds. Awesome. Okay, yep, just lock the doors. Nobody's getting any pizza. Yeah. Hi there. Let's see if I can make this full screen. Yes, in case anybody isn't in the right room, this is going to be a talk on Project Antipatterns. I am Mike. I have been coming to Rock Game Dev for a few months and found out that some talks would be a good idea for some of these things. And that is... Why is... Why, there we go. So, why am I going to be talking about all this stuff? I have done several different types of projects, some games related, some not. Seen where some stuff has succeeded, seen where some stuff has failed. As it turns out, I make most of the mistakes that we are going to be going over in this. I will try to point that out where it is. I do have examples for some of the ones I haven't made, and let's see. Sorry, this has just gotten out of order a bit. So, some things to go over. What are Project Antipatterns? How do they happen in a project? So what causes them? What conditions makes them more likely to occur? Why are they a bad thing to happen? Different antipatterns that you should look for. The term comes mostly from software development, so antipatterns in a source code base, but there are about half later on in the presentation will be just generally speaking for project management type stuff. And then are there ways to mitigate them? Are there ways to prevent them from happening in the first place? Now, some of the mistakes that I've made in the past, this is essentially putting the cart before the horse. for one of my I'm trying to design a tactics game. What do you need in tactics? You need a bunch of complicated systems that interact with each other. So before I even figure out what I need to do, I go off and create 30 subclasses for a feature that's not even going to be in there anymore. That's half of them. The other ones are, my desktop was too small to get the full screen cap. Why? That's out of order. Got some nice massive commits trying to do way too many things at once. In this case, I was doing a refactor for some type of 3D drawing, and also doing some refactoring, and also adding in a bunch of comments that I had forgotten to add in for months. And also another thing that's not even in the commit message, but I did it all at once. Massive functions, a lot of copying and pasting. You can see on the right side of the screen about 8 blocks that are repeated. This thing has been refactored at this point. Don't have source code in this presentation, but pretty much gave myself a 4-hour headache trying to clean up all of that because I had to add in new stuff in the middle, and when you copy and paste, you can't do that. So, probably should actually get into what antipatterns are. Back in the late 90s, there was a group of 4 software engineers that were trying to come up with, here are some general purpose techniques, like different ways you can style your code, different design patterns that you can use sort of to clean things up, different types of projects, make sure that everything is usable for the developers. That way you don't pull your hair out 6 months down the line when you have to go and change somebody else's code that is broken. This is actually called the Gang of 4 book. Probably required reading for anybody that wants to do UI design. Or at least for desktop application UI design. This is probably your go-to book. So, 3 years later, a response book to this came out for antipatterns. Essentially, things in source code that look correct at first but are not, and have been tried in the past, have failed spectacularly in the past, and have better and easier solutions that, if you know they exist, you can put those in with very little headache and undo a lot of the damage that you ended up doing in the past. So, how do antipatterns get into your project? Usually it's ignorance, it's not malice. Just by knowing that the patterns exist, you'll be able to find them easier and remove them faster. The main rule of thumb is if this code looks like it's wrong, or if this style of management seems like it's wrong, it probably is and you should change something. So these can come about by misallocating your time, misallocating your resources, either by, say, front-loading a bunch of work that you don't need to, 30 subclasses, prioritizing stuff that really should not be prioritized, like something that very basic project planning would have figured out, but because project planning is boring and we want to skip all of that, mistakes happen. Ease of implementation. Control-C, Control-V is a lot easier to do than think about a problem and actually create a new solution for it. If you Control-C, Control-V the wrong thing, you will have to fix things. Usually the antipatterns seem correct at first, like copying and pasting will get your code to work. Front-loading a bunch of stuff will technically work, unless, in my case, you don't use it. But the antipatterns are incorrect for a reason. Not realizing that these quick fixes will cause problems at scale is the main reason we want to get rid of them. Which mostly has to do with this post hoc fallacy, which I think the core logical fallacy for a lot of things is post hoc ergo propter hoc, which is after this, therefore because of this. So like, it rained today, and I had eggs, therefore the rain made me hungry for eggs. Apply that to your code base. Copying and pasting got this code to work. Or forcing my employees to work 80 hours a week pushed out our update on time. The part A and part B don't necessarily mean that A causes B just because B happened second. Which most of these are due to seeing the effects of B and thinking that A caused them correctly. The reason that we want to get rid of the antipatterns is because they are known to cause headaches over time. If you look at any large-scale project, but by large-scale I'm going to say anything that's running maybe 6 months to a year with multiple, 10, 20, 50 developers. Once you have a lot of people touching a lot of things at the same time, stuff is going to break. By including the antipatterns, it makes your code base more complicated and more likely that something is going to break it. The better solutions exist. You can find most of them on Wikipedia, like I did about an hour before this talk. And Google is also your friend. So start out with, I'm going to go over some of the source code related antipatterns, mostly because they are the ones I'm more familiar with. I should mention these aren't in any particular order. I'm mostly going to be writing or talking about them in the order that I thought to include them at first. So to start off with, nice, wonderful one, dependency hell, dependency heck. I'm not sure which one's more stream friendly, but essentially you have some code base that depends on some stuff, where some stuff depends on some other stuff, and somewhere down the line, one of your pieces is going to change. Depending on what you're doing, either that'll hopefully do nothing, might fail catastrophically. Usually this happens when you're dealing with some sort of like third-party applications, so any of your libraries, any of your engines, anything that somebody else wrote has a big update. In my case, this was a big update for, I believe it was the OpenGL versions, where, oh hey, we have a new version and it does all of this great stuff. And it also removes all of this old stuff that you were using because you didn't realize that it was 20 years old. And by not realizing that these changes are occurring and not planning for it, large pieces of your previously working code will break, all because you wanted to use some fancy new feature. Ideally, you want to figure out all of your versions ahead of time. Like, get to know every single tool that you're going to need. Have copies of those libraries, have copies of that engine somewhere offline in a stable version that if the company or the person that does the third-party stuff has an update, you don't need to install the update. That way, the code that you're currently working on will be static, and you won't have to worry about changing a lot of stuff. One place this comes up often is save files, loading files, anything where you add in more features. And since you had in more features, the versions are different. If you try to load a newer thing on an older platform, or vice versa, you might end up breaking a bunch of stuff. So when possible, have two separate versions of a thing if you need to load in multiple dependencies, because that way you'll be able to have both of them working separately. Then main key here, make sure that you have written down somewhere, these are all of the things that I'm using. If you have a list of stuff, it'll be easy to check that list and say, yep, I have version 6 of this thing, I have version 4 of this thing. If I stick to those versions, there won't be problems caused by somebody else putting a new thing out there. Let's see. Going on to another one, which I don't have a picture for. This one pretty much everybody knows is wrong, but ends up just happening on its own. Spaghetti code is caused by throwing stuff at the wall, and if it sticks, you leave it in because it works. Which, technically, does work. Downside is when you go back a month later and you have to add something new in the middle, how in the world are you going to figure out where that is? Generally, you see this happening if you have one file that does everything, something in the middle of that file is going to break, you're going to have a bad time. If you call out to a bunch of stuff in a bunch of places kind of randomly, probably a good sign that you need to redesign and move things into smaller components, somewhere that'll be easier to figure out stuff. The excessive indents, the non-standard logic flow, like if you have something that's 6-7 indents out, you have breaking in the middle of stuff, you have switches everywhere, most likely that is a sign that you're over-complicating the problem. It would most likely be easier to split that into smaller pieces. If I go to mitigations, oh, wait, I actually do have a picture for this one out of order again. You can kind of see the difference between the left side, which is, I can't remember which public library this one is, but the left side is written in a more standard style where things are kind of packaged into their own modules. Stuff follows a generally logical order. It's easier to find your way through places. The one on the right, not so much. Sadly, my project looks a bit more like the one on the right, but what can you do? Think before you leap. Again, if your code looks like it's wrong, most likely you have to change something about it. Probably by making things shorter, refactoring, moving stuff into smaller components that are easier to read, easier to maintain. If you call this thing, it doesn't do 10 things anymore, it does one thing, and it only does one thing. Style guides really help. The one that I'm using at work, for example, has a very set amount of space that you can use for each line in your project. If you go over this, it will yell at you, and you can't do anything until you make it shorter. Something like that would be a good idea. If you are going onto a project that has one of these, read it, follow it. It will save so many headaches in the future. Comment your code. Just good idea in general, but usually spaghetti code is the worst when you find something that somebody wrote years and years and years ago, and that person is now gone, and they did not tell anybody how it works, and nobody can tell how it works. So again, we have a thing where I work right now, which I believe was written in 1990 by a group on Usenet, and then shared by a bunch of people, made its way into a third-party thing, made its way into our stuff, which I can't remember how many go-tos, but we counted at least 20 in one file, which pretty much our goal for fixing that is we are not going to touch this ever, because if we do, we have absolutely no idea what's going to happen. If you can avoid that by any means, please do. Probably one of my favorite things, the golden hammer, which is when you're starting out, you probably know a tool or two. In this case, you have a wonderful hammer. It's a nice gold-plated hammer. You can do so many things with it. Like you can hammer a nail into a board. You can hammer a screw into a board. You can open up your windows at your house. You can really distract the neighbors from taking your cool stuff. So many uses, probably most of which you don't actually want to use a hammer for. The term goes back at least to biblical times, and I think first called golden hammer sometime in the 1800s. Pretty much, if you give a fool a golden hammer, everything looks like a nail. This is mostly caused by not knowing that other tools exist. A hammer is easy to use. A hammer can be used for many things. Hammer is not your best tool for every situation. Most of the ways to fix this are just explore, like, figure out other things that can go into your toolbox. Like, not everything has to be just, I am going to write this thing with only, say, pass in a bunch of stuff all at once in a straight, like, array vector, whatever. Have it deal with all of that. I'm only going to use that because it's the only thing that I know, and it works, and it's great. There are other things, like there are other ways you can manage your stuff. Probably would be a good idea to look into how did other people solve a similar problem to what you had. They will probably even tell you exactly which tools they're using. Do this before you heavily invest in golden hammers. If you wait too long, you're going to end up using this everywhere, which may or may not be a good thing. Don't be afraid to kill your darlings. Again, if something works, does not mean it's working the best that it can. If something isn't working as well as it could, and you know this is the thing that isn't working as well as it could, it is a good idea to go back and fix that. Like, it will be worth your time and effort, because eventually you will have some savings, time, effort down the line. Next one is one of my favorites. As a software person, I really enjoy to redo things that other people have done better and easier and cheaper and faster. And I should think of another adjective for that, but because I made this thing, it must be great and it must be useful. No. Making new things is fun, but you probably don't need to make all of the new things. Like, the hammer exists for a reason. You don't need to find a rock and pretend it's a hammer and just use a rock because you found a rock. Again, this is usually caused by a lack of research. Like, a tool for this probably exists, but it would take me at least 5 minutes to figure that out, and that's too much effort. So I'm just going to build my own. It'll only take, I don't know, 6 months, 12 months. It's my own. Which the time that you're spending on reinventing the wheel could be time that you're spending on, maybe you want to reinvent an axle, maybe you want to reinvent the bike frame. You know, something that could be better and more useful, and use that wheel that you found. Could be good for your time. Make sure, do your due diligence before you start on this, because it is very possible to try and fail to reinvent the wheel. If you spend a lot of time working on a solution that somebody already did, that is definitely, it's just a giant waste. Please try not to do that. If you can come up with something cool, like you want to build a wheel reflector, or you want to build, I don't know, a wheel trebuchet or something, probably more interesting, more fun, and less time than doing a new wheel. Make sure, look for and try the standard solution. Maybe your project doesn't need a square wheel, but try the round one first, because it might be all that you need. And as a side note, like, I am pretty big into security. I will say, if you have absolutely anything that might be a problem, if it was, say, hackable, never, 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 never reinvent the wheel for that. There is a reason that standards exist for security. If you go against those standards, most likely all you're doing is making your thing slower and more likely to be hacked. So just do your research as the main takeaway from there. And a wonderful one, shotgun surgery. This is trying to change a bunch of things in a bunch of places all at once. Hence my last commit. Not my most recent, but just one of the last ones that I thought was funny. As you can see, there is, I think it's 5 different components that are getting touched in there, of which only 2 of them actually needed to be touched. And all of the rest of it is just random refactoring that I decided to do and not commit on its own, which made this one take about 3 weeks to finish, just because I was doing way too many things in way too many places. Usually this will happen if everything is broken right now. I need to fix everything right now. Please split this up into multiple tasks. It will be much easier and faster if you do that. Usually you'll find this if you're like, I need to copy this thing everywhere or else everything will break. Copying and pasting by itself is not a good thing, but since you're doing it everywhere, there is a good chance that you are going to miss one of the spots that you have to do it, and there is a good chance you're going to try to fix something that isn't broken, which will end up breaking it, and end up making you do the amendment to that commit a few days later, saying, what were you thinking? Please do this right the next time. So, ways to do this: save early, save often, save in chunks that are small enough that the person reading it knows exactly what you're doing. Also, second side note, version control is your friend. A, it will give you funny messages like that to look back on and cringe, but B, if you have some mistake that ends up breaking things permanently, you can just roll it back and raise the earth, start over, without just losing everything, which I did lose a hard drive recently. If I was not using this stuff, I would have probably lost over a year of work. Please use version control. I cannot stress that enough. Back to shotgun surgery. Don't copy and paste something to multiple places. If you're doing that, that's a sign that this one thing needs to be put in one spot that all of those other places can get to. Whether or not that works, it might turn your code into spaghetti, in which case, whatever you did the first time was incorrect. It is time to go back and look at stuff and do a redesign, make things easier to follow, because it will, in the future, pay its dividends. Other way to do this, make sure that you have tests in your code. This way, if you try to fix a bunch of things at once, you're able to run your tests before you end up finalizing all your changes. If you have a nice set of automated tests, you're able to make sure that none of your old stuff is actually broken. Good idea in general, but definitely if you're changing a bunch of stuff all at the same time. Magic numbers, another pretty good idea of something that should be in one place. Usually you find this with either math constants or, say, global variables. I'm only going to have 4 columns in this list, or the height is 800 pixels, something like that. If you just use the normal number everywhere, so instead of saying, height, you say 800. First off, now you have to find 800 somewhere in your files. Second off, there are going to be other things that have 800 inside of them that are completely unrelated to your height. And if you try to do it quickly, find paste, you will find all of them, and now stuff is broken again. Also goes in with the typos. If you end up making a typo in one of your magic numbers, and you try to find and replace all of them, you are going to miss that one, and you're not going to be able to find it again. Ways to fix this: name your constants. Also, side note, make sure that they actually are constant. If you're able to change them somewhere, all of the other things referring back to this essentially, magic number will possibly break unless you are absolutely 100% sure that that is what you want to do and you know what you're doing. Not great when you're working on a team with a bunch of other people that are trying to do the same thing. Good idea to do this for, say, math constants. Like, just have some file with a bunch of those. Chances are good your libraries will have something like that in there already. If they do, great, use them. If not, just make sure that they're in one place, preferably commented so it's easy to find. If you ever use the same magic number in more than one spot, move that somewhere else that it can be named once, because that way you don't end up having to change it in multiple places. Does not have to just be a number. It can be, say, a file path. It can be a database ID. Pretty much anything that's supposed to be unique. I think that the one example that I had that I wasn't able to put in here for sweary reasons, back in Quake in the late 90s, there was a comment for some random hexadecimal number that made it very easy to do lights in the game, which the comment had nothing to do with what the math was actually doing. So it's a useful tool, but nowhere in the source code at all does it tell you what that number actually is. Mostly because I looked about an hour to see how they came up with that exact number, and as far as I can tell, they don't know either. Guesswork, not exactly great. Moving on, another one that mostly you find in desktop applications, but can apply to some games. The big red button. My example for this would have been last year's tax return. Here is a wonderful PDF with 100 forms that you have to fill out in it. Name, phone number, social security, whatever. And fill out all of these, and then there's a big red button at the bottom that says submit. And you click on it, and the screen loads for a minute, and it comes back saying one of these fields was wrong. We've gone through the liberty of erasing all of them for you, so you're able to try again and make sure that they're right this time. Which I should have gotten the gif of Ron Swanson throwing the computer into the dumpster at that point, because that's about what happens in this. Usually this is noticeable when the form that you're trying to enter doesn't have any error checking. We have to type a phone number into this field for some reason. And for whatever reason, you let the person type in letters, so their phone number has the letter O in it. If you're following this hit go when everything is done mentality, you will end up having, you get to the end of the form, you hit go, it breaks. Maybe at that point they'll tell, oh, you have an O in here, but most likely it'll just be something somewhere was wrong. Which leads me into the next section for affordances. Finally, a picture of a game. This is a tactics game called Disgaea. The idea of which in this screenshot is, as one of the main mechanics, you're able to queue up a bunch of actions that happen all at once. And when you hit go, if the actions happen successfully on the enemy team, the chances that they'll succeed get better and better and better. Just looking at this picture, you can see the diamonds with the E on them. The E says that their turn has been ended, which means that their action has been finalized. From this picture, you have absolutely zero idea what any of them are actually about to do, which is made doubly bad by the fact that there isn't an undo option. The best you can do is erase everything and start from scratch, which really could be fixed by just adding in a couple more icons, like, I'm going to attack that person and I'm going to do it first. So make some nice swords with a 1. I'm going to heal my friend. I'm doing it second, make a cross with a 2. Something that's much newer game, did successfully. Of course, in this one, it's a bit different. This is Into the Breach, by the way. Much more recent tactics game. All of the queuing up of actions is done on the AI turn instead of yours, which helps the player not have to remember everything that's going to happen, because you can just pull up this list of things that are going to happen at any point in time. And then B, you have a nice label in the top right corner that says these are what the numbers mean. And then on the map you have numbers with attached to the thing that's going to do the action, and then a nice little red line saying this is where the action is going, and then a nice little icon on the target that says this is what it's going to do, which there's a good GDC talk that these developers did for exactly how long these affordances took to make. I believe it was longer than FTL. Just trying to figure out how to make this, how to make the players understand what's happening took several years of iteration for them to get right. But in my opinion, they did a great job at it. Things that you can do to sort of eliminate this problem. If you have something complicated that the user has to do, make sure that you tell them if something is wrong before they try to do it. Ideally, you don't want to have all of the queuing of actions at all, because people, I think, can on average memorize maybe a phone number worth of stuff, if that. So once you try to make people memorize more than, say, 7 digits, somebody is going to forget something. It will make things harder on them, which probably is not intended. So if you absolutely need to have all of these stuff happen at once, make sure that you detect the invalid input, prevent it from happening if you can, warn the person that this is going to happen if you can't. If at all possible, add in as many things that you can to make it easier on your end user. Any amount of affordances that you can add in, make the colors pop out on stuff that's important, make the text easy to read, give you nice numbers for this is the order that stuff is going to happen in. Anything like that can make somebody's day a little bit easier, which makes it worthwhile to do. Now to move on to some of the less codey aspects of this. So I have a little bit of an example meeting for you. This is a meeting for the Joint Tactics Nuclear Test Facility. So we are going to have a nice discussion on the launch codes for our missiles. Then we're going to have a quick aside. We're repainting the lobby, and we want to fix some of the lighting in there, so we have to figure out the budget for that. And we would really like a new coffee maker in the break room. We want to figure out what kind of coffee maker. What actually ends up happening in that meeting, nuclear physics is hard, so we're going to spend as little time with that as possible, because, it's the solution that we came up with first will probably be the right one that works. Fixing up the interior of a room, most people will be able to understand that, ends up taking most of the time. And trying to figure out who wants which kind of coffee maker, who wants which type of coffee. You have the one friend that likes tea and will not have coffee whatsoever. Ends up making your meeting very, very lopsided. The original example for this used a bicycle shed, but I haven't actually seen one at any of my buildings. So I think the lobby renovation is probably more accurate for this. Fighting over small details is a lot easier than fighting over large ones, since the small details are easier to understand. What this ends up happening... I should have deleted one of those lines in there. Pretty much ends up making your estimates just throw them out the window, because you have the nuclear launch code discussion. You have the, I want to design, here is what the sound in the game is going to be like. Here is what the art is going to be like. Probably should take a lot of time. Will probably end up being a lot of time loaded on the front end by people that aren't talking to each other, pulled into a meeting, and then come up with a very big number for this is the amount of money and this is the amount of time that we have. And because most of that work was done beforehand without collaborating, usually the first answer is going to be the correct one if the number sounds low enough that it could be good. One example where this ended up coming up was I think it was an old DOS game called Battle Chess, where to avoid this problem, one of the animators decided, I really want to have my animation the way that it should be, and I know that my superiors are going to complain about this because if they don't, they have no other purpose in this besides telling me things that I did wrong. So he ended up animating a queen walking around and standing still and attacking and all that, but added in a duck, like a dancing duck, to every frame in that. So the managers come to see that. This thing is great. We have, the animation looks very nice, but just get rid of the duck. Ended up working out for them. Some ways to get around this: make sure that if you have a schedule, you stick to it. It helps if you budget out, this is how long this part of the discussion is going to take. Do that ahead of time. Most likely a good idea to only have one discussion per meeting. Like the nuclear launch codes meeting should not be talking about coffee makers. Just to put that there. It helps if you do short meetings more often than if you do long meetings up front, just because that way if people have thoughts in between or something ends up changing down the line, you'll be able to catch it quicker. You probably will end up having one big meeting up front, but it helps to continue with, it can even just be a couple minutes a day, just, is this thing working, yes or no? And if it's not, what can we do to fix it? We'll solve so many headaches. This law is, I can't remember this person's first name, but Brooks was the author of a book called The Mythical Man Month, who decided to do a case study for a bunch of Fortune 500 companies running their software projects. Essentially figured out that one person working 1 month could mean a lot of things depending on the state of it, and basically that trying to keep track of this was mostly useless. As part of that book, one of the discussions that ended up getting found was that it takes a lot of time to, if you have a large team and you need to get a new hire into your large team, somebody in that team is going to have to help the new person figure out where is everything, what am I going to be doing here, how do I get into my locker, what's the password for the lab door, stuff like that. Even stuff, what coding style do you use, what tools are here, how do I use them. This is going to drag probably one of your most experienced people out of a productive role for quite a while they bring a new person up to speed. I think it, Google, Amazon, those types of places, that takes 6 months because their stuff is so big that you need that long just to get your head wrapped around all of it. What Brooks ended up finding out is that if you try to do this on a late project, it will end up you have something that is behind schedule, and you think that hiring more people to do more work, alternatively making more people do overtime to do more work, you think that will make the thing come out the door faster. It might, it probably won't, and it will always cost you more money. And I have a hastily drawn graph to prove this. essentially, this point, about 2/3 the way down the line, is where they realize we are very behind schedule. Well, slightly behind schedule, but somewhat behind schedule. And we need to hire somebody new to help us with this workload. The goal being to make the red line cross over the solid black line some point before the project is finished. What ends up happening is there is an onboarding period right about here. During this onboarding period, some of the senior people are pulled off of their tasks. They are doing things that aren't job-related, really. They're doing things that are more person-related. Still useful, because in the future, the productivity actually does go faster than it had been at the beginning. But at the point where it begins to go faster, the deadline has been missed by more than if somebody new was not brought in. So some ways to make the onboarding period go smoother: write everything down. Make sure that if you have a procedure that people need to follow, don't have it be just something that you have to remember, because when you get the new person, somebody will have to tell them. It's much faster to tell somebody this is where you find the procedure than this is the procedure. I'm going to repeat it a bunch of times so that I'm not misremembering it, and it'll take a lot of time off on the project. Make sure that you actually have enough time and resources to do the hiring. No matter what, bringing more people onto a project will cost more. If you run out of money before you hit that top line, it's going to cost you more money quicker to hire the new person, which is going to make things even less likely to come out on time. Try not to pull your main project leads, because they will be doing they'll be doing the bulk of the actual work. If at all possible, try to get somebody whose role it is specifically to onboard these people. Then one note at the bottom here, if you have a late project that is behind on time and behind on budget, that is really something that should have been planned out at the beginning. It is not the fault of the people working on the project. Usually speaking, most people are good. The coders, the artists, the animators, the designers, the project managers alike, everybody is a good person that wants to make this thing succeed. If there wasn't enough time and budget to do this, that either means A, something that we thought would happen happened, or B, something that we did not expect to happen happened. Really, all of the if you go into a project knowing that the time and budget can't actually meet your deadline, that is on the project manager, not on the person trying to do that. Crunching is not more productive. It will not help. It's only going to drain your resources even faster. Very different jump here. This is putting the cart before the horse. I believe I showed that example earlier. Essentially doing your project out of order. Most often this happens by being very excited about the thing that I want to make and just hacking through a bunch of stuff quickly, and then realizing, oh wait, this isn't what I wanted. I really should have planned this. Going back to do a bunch of planning, realizing all of your future stuff is going to be different than that, and having to scrap weeks worth of work on something that could have been avoided. This will often happen if you have a lot of, you have to have some kind of legal or either, say, a government project, or you're working with, say, medical data, something like that. Not so often on games unless you are getting into, actually working for a casino. Somebody on your team will have to research all of the legalese and make sure everything is up to standards, which, if you don't do ahead of time, will end up you make a slot machine, you realize the slot machine is illegal, after you've already made the thing, and now you have to remake it. Ways to get around this: only create features that you know that you're going to need. The way to know that you will need a feature is to do the work up front, actually go through your design, figure out, I need this component to do this thing, I need this component to do this thing. Do that ahead of time. Make sure that your features are finished before you write the test for them, or at the very least know that you have, I need to test this piece. There are some strategies where it's possible to do the test prior to doing the actual thing that works, but that only functions if you already know ahead of time, this is the end product that I want. Make sure that risk calculation is a good thing. You want to have that for pretty much any project that's going to involve a lot of time and money. Cap the risks at the ones that are actually likely to affect your project. Having a tool that doesn't do everything that you need, or having one of your developers quit halfway through the development process is much more likely than a meteor striking RIT. Probably do not have to put that one into your assessment. And then again, I am a proponent of short, frequent meetings to just make sure these are the things that I need to do. If you do, short is probably 1 minute per person just at the beginning of every day. These are the things that I did, these are the things I'm going to do. If you do that frequently, you'll be able to essentially get your planning done very, very, very quickly, which will help make things go quite a bit faster. Next one is a wonderful picture for groupthink. Essentially, a lot of people get together that have similar ideas and don't realize that ideas outside of their group can exist. Or when they hear an idea outside of their group, they discount it because it did not come from inside of the group. This is not actually a sign of a bad team. This is a team that works well together, that unfortunately has begun to think the same way and stop disagreeing with each other, either through, say, peer pressure or through trying to find a lot of very similar people to do the same thing. Also can be caused by time pressure. If something is behind schedule, it is very easy to say, this is what we are going to do. We have to do this. If we don't, we are going to be late. It can cause people to agree with things that they might not otherwise agree with, because disagreeing would mean risking their team, risking the relationships that they've made. Mostly this is a problem because it creates very samey ideas, or very samey output, I should say. Since you don't have new ideas coming into the group, mostly your work will end up being the same over and over and over again, which is not great for games because, it's interactive and it's artistic and it's pretty much has to be a little bit unique for anybody to want to switch from something else and play what you have to offer. Some mitigation for this: aim for diverse skill set, diverse ideas. Try to make sure that your team has a bunch of different expertise, different ideas coming into the project. It makes it more likely that there will be a period at the beginning where they will disagree, but if you have the right culture for your team, the disagreement period will end probably before you start heavy-duty work on whatever it is that you're doing, which will help you down the line because now your ideas are coming from multiple people instead of the one person who happens to be controlling the conversation. Have some way for team members to raise their concerns as soon as possible. This could be, because of this, the project will be late, or if we do this, it will not be as good as if we did this. Make sure that there's a way for everybody on your team to express those ideas without consequences. Like, if you have one person controlling the conversation, that shuts down any kind of disagreement because it will make them incorrect. Probably not the best management style for that. Make sure that you listen to everybody on your team, the most senior member, the least senior member, the janitor in the building even. You can get good ideas from anywhere. It will help you to ask people outside of your team, how is this plan that we're doing? Is it correct? Is it a thing that would be a good idea? Can work with your, say, your testers, like random people at conventions, fine. It helps the most if you get somebody that actually knows their subject matter. Like, even coming to this meeting is a good example. Like, getting info from other developers is probably going to be more accurate than getting info from your current players as far as the technical side of things go. As far as the gameplay side of things go, in that case, your players and your testers are your subject experts. Don't discount what they have to say. They probably do have a good point when they are saying it. And last, and in my opinion least, this isn't an anti-pattern so much as it is just bad project management. But in this case, micromanagement of the minutia of your project ends up happening because somebody is in a position of power that they want to keep, either through stress of the job or some kind of bonuses related to their management style, or just not being experienced and not realizing these things are going to be bad. Thankfully, I can say I've never experienced this personally. I've heard horror stories from some other friends about micromanagers, but usually what this will be expressed with is excessive keeping of metrics. For example, very, very strict time logging, quotas for output, trying to make sure that X amount of work has been completed at all times. Usually related to some kind of, say, performance review. So, like, if you do not get X quota of work done, something bad will happen, and it is my job to force you to get X amount of work done, regardless of the results that happen to you, which will probably involve some kind of unrealistic expectations, crunch time, overtime, stress on the job, yelling from your boss, horrible conversations, threats, essentially everything to do with a hostile work environment. This is going to lead to, for the team, a lot of stress, a lot of mistakes. It will make the output worse. For the manager, honestly, it's probably going to be okay for them for at least the short term. It is far easier to replace somebody in the middle of a team, sadly, than it is to replace somebody that is controlling the output of a team. But this will lead to poor results and quite possibly the failure of the entire project as a whole. My main suggestion for micromanagement is just don't do it. It's ineffective. It's going to cause problems with any of your employees. If you're in a position, if you can manage somebody, please do not micromanage. There are guides online for how to not do that. Please read those if you ever become a manager. Follow those. Don't do it. It's not worth it. As far as the metrics go, metrics would be anything along the lines of, say, time worked on an event, amount of code produced, number of pictures drawn, anything like that. Using metrics as say, if you do X amount of work, you will get X amount of bonus. Or say, if you don't do X amount of work, there will be a bad performance review. That does not cause people to do more work. That causes people to do work that make the metrics pass. So chances are good less work will actually be getting done. The metrics will look better, but only because the people are working to do the metrics and not the other way around. If something isn't useful for actually planning future projects, it's not worth keeping track of. If something isn't useful for planning, say, this is the work that I'm able to do, how far down the line? If it's not directly useful for that, it's a waste of time to keep track of that. Make sure that there are some ways for anybody that you are managing to explain these are some issues that I've been having. This is where I feel that the organization has been failing. Make sure there's some place to express that doesn't involve the threat of losing a job. Because if you don't have that, people will keep problems to themselves until they're too bad to fix. Micromanagement leads to a bad first impression. When somebody leaves your team because of micromanagement, they are going to tell that to everyone they meet that asks about that group, that company. This boss at this place was the worst boss that I've ever had. You do not want to be that person, and you do not want to run a company that has that person as one of your bosses. Try to catch this ahead of time and nip it in the bud before it gets too bad. Those are actually out of order. Since those are out of order, I do have another one. Scope creep happens in pretty much every project, but ideally you want to keep this to a minimum, because I believe I'm running out of time a bit. If you have a plan going forward, it'll be a lot easier to minimize this. For example, you are making some type of, let's call it World War II Simulator 2020. And somebody down the line says, we also want to add Battle Royale to this. If that wasn't in your plan at the beginning, and you've already started work on World War II Simulator 2020, it might not be the best use of resources to just tack that on at the end, because it's going to cost a lot of extra money, it's going to take a lot of extra time, and it might not be the type of thing that your players actually want. So make sure, know what it is you're going to make before you make it. If you decide, no, World War II Simulator 2020 actually does need Battle Royale in it because we could do it this way to be useful, don't use the same estimate that you had for game without feature, because that estimate has now been thrown out the window. You just added a lot of extra time and money that you will need to spend. If you forget to update your original estimate, you're going to miss it. Again, scope creep is not a failure of the people that are making the project. The people that are making the project, as are the people that are managing the project, want to make something that works, and they want to make something that works well. If you want to make a 5-year thing happen in 3 years, you are going to need 5/3 as many people, probably double as many people, and you're going to need them up front. If you don't have those resources up front, that is not a fault of the people that are building the project. That is not an excuse to do crunch time. Again, crunch time is counterproductive. At best, you're going to get a lot of tired people writing a bunch of mistakes. Don't do it. Then finally, a couple of slides for how to sort of see some of these happening beforehand and prevent them from happening at all. One thing that any project needs is risk assessment beforehand. Usually this is done throughout and continuously updated. Not the best idea to do it all in one chunk at the beginning and then never look at it again. Should be a living document. But the main idea for this is I and all of the people that I know that are going to be working on the project will brainstorm. These are the things that are most likely to make the project later and more expensive. So, somebody's computer breaks, or somebody leaves the project for whatever reason. The tools that I needed to use don't actually do what I wanted them to. Anything along those lines. The building getting hit by a meteor, not so much. Try to keep them realistic. Well, I actually said no velociraptor attacks. Probably should have read that one out loud. I have an example for this on the next slide, but the gist of this is you're able to estimate a time and or dollar sign budget for how likely is this going to go wrong. So if somebody leaves the team, for example, it will cost, say, a month and $10,000 extra just to hire a new person to refill that role. So if you estimate that your chances of that happening are, say, 50%, which they should not be, why is there a 50% chance somebody will leave? You should probably fix that. But $10,000 and a month times the 50% chance it'll happen says that you should tack on about 2 weeks and $5,000 to your final estimate, because that's basically the average value of the thing that will happen. Make sure that you have as much input as you can to figure out all of this stuff. It'll make the dollar sign number more accurate. It'll make the time estimate more accurate. I have an example for that, which is surprisingly less blurry on this big screen. Essentially, some chart with these are the things that could go wrong. These are the chances that we think they will go wrong. Most places use very, very rough numbers for this. So you don't have to calculate. There's like a 7.5% chance that this will happen. And like 20% increments are probably fine. 10% if you're really, if you really need to get that accurate, maybe 10% increments. Then the likelihood that or the number of either days, dollars, stuff that you need to change, lines of code, whatever, lost because of this. Try to make sure that pretty much that second number is the one where you're going to need your most team input. Probably better to be pessimistic, but not too pessimistic with that. If you make all of your risks cost a lot less than they actually will, all that is going to do is make your estimate more likely to fail. Another good thing that wasn't on this chart, but I couldn't find on Google image search, would be 2 extra columns on the right side of this. One column for this. These are the signs that this is going to happen. If we start seeing these signs, this is what we're going to do to try to prevent that risk from happening. And then a second column after that says, once this happens, this is how we're going to fix it. Which, having an actual plan set up for those two things will, A, reduce your cost for the risk, and B, hopefully reduce the probability that they happen in the first place. Just generally a good thing to have. And then finally, testing your code. I'm a big proponent of this, and I probably should be doing it, but make sure that you actually have stuff written that isn't manual. If you're manually testing everything, chances are good that at some point you will miss one of the tests, and of course it'll be the one time that you miss the test that it broke. Different places that you can do this. Code level unit testing is something that pretty much code that runs against your code, and if you're not familiar with it, you pass run this subset of my code with this input, and I want to see this output, which you're able to do that automatically. Like just hit the button that says run all of the tests. It'll tell you which ones are passing and failing. When you have these sort of tests, you need to make sure that they are passing before you change, like before you finalize any of your changes. Anything that says this test should pass needs to be passing, especially for the code level ones. If you have a failing test, that's just a sign that something somewhere is broken. You don't want that. Probably a good idea to have. There are tools, trying to think of names, but for continuous integration, which is you put this sort of in your version control pipeline, and when you try to turn in your changes, you have pretty much all that stuff run automatically for you. That will flag it if it goes wrong. Depending on your settings, will not even let you put a thing in there that goes wrong. Integration testing is somewhere in between these, like somewhere in between the first and third, essentially testing the talk between your components. Some of it can be automated, some of it probably can't be, but in general, something that you will want to have a written test plan for if you have anything of scale. System level testing is going to be something that you, the user, or some end user will end up doing, making sure, do all of my buttons work? Can I load and save, and can I do all of the main features that I think I will need? Again, written test plan for that. And then finally, something that you will definitely want is user testing, some kind of feedback for the actual content of the stuff that you're doing. Could be done with, say, reviews if you're going to be updating your game. Could be done, go to Maker Faire, I think, is coming up. Go to any event like that. Make sure that you have some way to talk with your actual players, because A, they'll appreciate that, and B, it's the fastest way to figure out that something is wrong, is when it goes wrong and somebody tells you about it very loudly. I believe that is all that I have. So, I've been Mike. I have some shameless self-promotion. I will be making these slides available on the Discord shortly after this meeting, probably going to remove some of the pictures that have nothing else attached. But with that, I think that's everything that I have. Do we have any questions in here? Yes.
So at the end there you mentioned testing. So unit tests and integration tests and other tests like that are their own separate code base that you need to write and also maintain along your code as you develop it, and that's also kind of a dependency that needs to change in response to, like, if some system in your game changes, you need to change the tests that test that system.
Yes, that is true. Probably I probably glossed over that a bit. If you know that some of your past tests are going to change, you will need to change the old tests that are no longer valid. Like the tests, as the code, as all the other documents, are living documents. But yes, you're 100% right on that.
Well, the specific question is that can add a lot of development time to a project. At what, like, is there a point at which, like, you're writing too, like, obviously there's a point at which you're writing too many tests. Like, you know.
Yes. So there is. It's sort of hard to quantify, but generally speaking, you will have enough tests to run through 100% of the most important pieces of your code. But by the most important, I mean like stuff like, I need to load this specific save file and make sure that the game doesn't crash. or I need to make sure I have a database. I need to grab something from that database and make sure that it has the correct values in it. Like stuff like that should never be broken by another change unless you're specifically targeting those components. Pieces like that, you probably want to test 100% of the lines of code. Make sure that every possibility gets hit. For looser requirements, like I need to make sure things go this fast, or I need to make sure that everything loads correctly. Like the screen looks perfect, the music is playing at exactly the right time. Probably there won't be a unit test for that because it's writing something that would actually work for something like that would take absolutely forever. Usually for a large team, there will be a dedicated testing department that will write all of these after the fact. Like say somebody put in a new level, and we want to make sure that that level is loading correctly. Somebody writes a test for that. For smaller groups, it's easier to write the test yourself after you finish the feature. Usually, it will add. If you're writing your code in a way that things are modular, individual tests will not take that much longer to write, and it'll save you a lot more time when you're trying to find the bugs than it will to write the test themselves. Yep. Any other questions? Yes.
So when you mentioned that when you're talking about these code-based testing things, is the idea to take the code you want to test, like you've got this block of code that does this thing with this input and returns this, then do you take that code and then you give it a specific input and then check to see if it's got an output, or is there like an automated tool and like Visual Studio and stuff that...
Sorry.
Can you please restate the question for the stream?
Oh, yep. So the question for that was when you're writing a unit code test specifically, would it be something where you read through the code, it's looking for this input, this output, do you just ask that chunk of code, here is input, I want this output back? Yes, that is 100% what you're doing. Because you should know and probably have commented, this is the output that I expect from this thing. Your unit test is just writing that down permanently. Make sure that there's actually some way to know that that critical thing has not changed yet. Yep. Any other? Yes.
Do you have any strategies in pre-production to head off some of the bad stuff?
In pre-production.
Like design documents or...
Okay, so any design documents or something like that to head off some of the bad stuff. For large organizations, there's quite a few things that are useful. Goal one is make sure that you have your actual, just sort of like a 1-2 page game design brief. This is the style of thing that I want. These are what I'm going to have in it. It'll probably help to have some kind of requirements document for your major features. Going very nitty gritty, we will have levels that load in under one frame. Probably not something that you need to get that detailed for, at least in pre-production. But stuff like we are going to have, these kind of assets are going to get put in, and this is when we are going to do them. We are going to have these types of files. We are going to have these types of levels. Doing that up front. Coming up with your risks up front, these are the people that I know I'm going to be working with. These are our schedules. These are the chances that something could go wrong. Write that down. Probably would be a good idea as well to have some sort of plan for this is what our code internally will look like. So for example, do we use tabs or spaces? How many spaces if we are doing that? what language are we using? What tools for the language are we specifically going to leave out? For that latter case, this is just drawing from my work experience. We have a 20-page code standards document, but that's because we're doing a government project. If you're working on something smaller, you probably do not need anywhere near that much detail. And then other things like one very good document to have is this is how to build the project, and this is how to set up all the tools to build the project. Because eventually you will need a new computer, and you will forget how to do that. Because my computer's in the corner right now, but that's my second computer, and right now my old engine does not build. I know how to fix it, I just haven't got around to it yet. Yes, any other questions? Yes?
So, a lot of the things you've been talking about tonight, you've been qualifying it with large-scale kind of productions. I will comment that I think a lot of these things are relevant to small-scale productions as well. But my question
Yes.
is more of not just small-scale, but very, very long-time productions. How do you see, over the course of, say, like a 5-year project, what are some of the most key things to be aware of from the things you discuss?
Okay, so for a maybe small team size but long time project, which of these anti-patterns are the most important to consider? That is a good question. I would say, first things first, make sure, probably the most important one there is the cart before the horse. Even if you're a team of one, and even if your project is taking one day at a game jam, it is probably a good idea to have at least 5 minutes up front to write yourself a quick note that says, these are the things that I want to make. If you have a list of these are the things that I want to make, you are much less likely to make stuff that you don't need. The number one time sink for any small team project is making stuff you don't need. Since your team is so small, like if you have, say, 2 developers and one person is doing something they don't need to, you just lost 50% of your production. If you're like me and you have 1 developer at the moment, you've lost all of your production, something that you would really want to avoid. Other good ones, I'm not sure of specific patterns to look for, but I'd say specifically one general take for all of this, if something looks like it's wrong, it probably is, and you should fix it. Goes for quite a few of them, like the spaghetti code, the dependencies, all of that. If you write a thing, or you draw a thing, or you music a thing, because that's a word, if you do something on your project, and it looks like it's not right, it probably isn't, and that is a thing that you should look to fix.
Thank you.
Oh, definitely. Anybody else? Questions, comments, bribes, anything of that nature? Looks like we're good.
So you said you'll be posting slides on Discord?
I will be posting those shortly after this. Believe I need to remove a couple of the picture-only slides because they don't work in PDF form. But apart from that, thank you all. You've been great. I've been Mike. You can find me in places in that shameless self-promotion, which I'm not sure. I think this laptop might be dead, actually.
Whoops.
Well, in that case,
Perfect timing.
thank you very much.
Thank you.